Hi friends, welcome back to my channel on statistics. If you are seeing my videos first time, then do subscribe. Let's go to the topic. In the before videos, I explained about unbiasedness. Now, mainly we are dealing with best estimate properties. Mainly we discussed unbiasedness, consistency, and efficiency. And one more important result is sufficiency. When our test statistics satisfy these four results, then we can say that it is best estimator. Okay. What sufficiency told says means literally we need to define conditional distribution of test statistics given t, then it is independent of parameter, then we can say that it is sufficiency, otherwise it is not sufficient statistics. Now I will give you first definition of sufficiency, then I will there are lot of important results are there in sufficiency. After results we can move to the examples. First we can see what is definition. See, sufficiency. An estimator is said to be sufficient for a parameter if it contains all the information. See, this is if it contains all the information in the sample regarding to the parameter. Okay, this point is clear. More precisely, if t equal to if this is our test statistic is an estimator of a parameter theta based on a sample values of size n from population with densities. This is our density function. Okay, such that the conditional distribution of x1 x2 and so on xn given t is independent of theta, then we can say that it is sufficient estimator for theta. See, this is the actual definition. Conditional distribution of x1 x2 and so on xn given t is independent of that distribution of parameter, then we can say that it is sufficient estimator. What is the role of sufficiency means unbiased, there is infinite number of unbiased numbers exist. After unbiasedness, consistency is important. After consistency, if you take normally, I will in the before video also explain this example. If you take normal distribution x bar and mean deviation, both are unbiasedness and consistency. Now our conclusion is what, which statistics I can select, either x bar either median. That time we are using efficiency. Okay, efficiency means we can take the variances, then which variance is minimum, then I can say that it is best estimator. Now question is sufficiency means by understanding the sufficiency we get the total information from the sample. It is important role in data direction. Okay, we get total information from the sample, so it is best property for for ideal estimator. Now we are going to the important results. Before going to the result, I will give you simple example related to the conditional distribution. In every distribution, finding conditional distribution is difficult and very lengthy also. There is some results also there, we can discuss it. See, this is the simple example related to the conditional distribution. Let x1 x2 and so on xn be a random sample from a Bernoulli population with parameter. You all know that p lies between 0 to 1. Here xi is 1 for probability success and for 0 for failure. I am taking one test statistic t equal to t of x1 x2 and so on. Here my statistics is x1 plus x2 plus and so on xn. Okay, we all are know that sum of binomial variates Bernoulli variates follows binomial distribution with parameters n comma p. Okay, sum of Bernoulli variates follows binomial distribution with parameter p. Okay, this is the PMF of binomial distribution. Now what is our question means, here test statistic is this. Our what is the definition? Conditional distribution of x1 x2 and so on xn given t. Okay, see this here, probability of x1 intersection x2 intersection x3 and so on xn given t equal to k. I am taking k, you can take different notations also. We all know that introduction probability of a given b is probability of a given b. This is conditional probability is probability of a intersection b divides probability of b when they are not independent. If they are independent, we can get probability of a only. Probability of a intersection b divides probability of b. This is the probability of a given formula. You can just apply probability of a given. See here, x1 up to xn intersection t equal to, this is the t equal to k. Now intersection of x1, x2 and so on xn, finally you got p power k into 1 minus p power n minus k. Here this is the intersection part. NCK is not intersection part, so I am taking this is the not intersection part. When you can dissolve, finally you got this cancelled, finally you got 1 upon NCK. Here this is the independent of parameter p, so it is the summation of xi is the sufficient statistics for the given family of distributions. Either you can take the binomial distribution. Okay, this is simple example. In every distributions, finding conditional distribution is difficult. If you take normal distribution or gamma distribution, in the distributions you face lot of difficulties for finding conditional distributions. Now we can see some results are there, that results are very important. This is the first result, factorization theorem. This is the first result, factorization theorem. What theorem says? The necessary and sufficient condition for a distribution to admit sufficient statistics is provided by factorization theorem. See what factorization theorem says. Statement: t equal to t of x, this is our t is our test statistic, is sufficient for theta if and only if the joint density function, I am taking one joint density function, it is denoted by capital L, so you can take different notations also, of the sample values can be expressed in the form. This is the form of, if I take any distribution, then I can arrange the distribution in this form. Here g of t is the dependent on parameter, here h of x is independent of parameter. Also here clearly is there, we can first we can understand this. Okay, for this is the main form of, here this is we have exact form. Okay, this is Kopman's form. L equal to L of x comma t, g of x into h of x into exponential form. See here, h of x and a of theta are function of parameters theta only, and g of x and omega x are the function of sample observations only. Okay, here g of t of x is dependent of theta, then h of x, these all are the independent of theta. Okay, now we are going to the, these are also some important results, invariance property and Fisher-Neyman criteria. This is less uses now, because this is, I think this is Fisher-Neyman factorization theorem too. Okay, you can read, you can understand. For proofs you can refer book. Now main important is examples, how sufficient statistics is useful in examples. Now we are going to the example. This is my simple example. See, let x1, x2 and so on xn be a random sample from a uniform population on 0 comma theta. Find a sufficient statistics for theta. This question is important. Here or the statistics is useful. See, they are saying that our xi IID random samples follows uniform distribution with parameter 0 comma theta. Okay, parameter 0 comma theta. Now we now know that what is the PDF of uniform distribution is 1 upon b minus a. If 1 upon b minus a, 1 by theta minus 0 is theta. Here limits are 0 less than xi less than theta, x less than theta. We are 0, otherwise this is the PDF of uniform distribution. Okay, here one more important is this indicator function. Indicator, this function is useful in this question, so I am writing here indicator of xy. Indicator is just constant function, indicator function. 1 if x less than y, 0 when x greater than y. This is indicator function. We all know that indicator function variance is 0, mean is 1. Okay, this is our indicator function. This is the PDF of uniform distribution for the given values. Okay, now I need to find joint distribution. For finding joint distribution, I am taking L equal to here multiplication is there, multiplication by I equal, here I start from 1 to n, here f of xi. Okay, here you can understand equal to finally I got pi of, here values are from 0 to 0 to xi and xi to theta. This is, see, 0 to xi and xi to theta. If you formulate graphically, you can understand. See, this is my real line. Here I have theta power. When I have joint distribution means theta power n times. Here I have 1. Okay, this is my function. G of theta of statistics x into h of x. Okay, if you understand this graph, you can easily say that what is the sufficient statistics for this. Here 0 to xi is minimum and xi to theta is maximum, in which in the graph where total data lies, that is the sufficient statistics. Means most information, where you get most information, that is the sufficient statistics for the given data. See, in the maximum case, you get most information from the sample, so maximum of xi is the sufficient statistics for the theta. Okay, this graph is where you get most information from the sample, that is the sufficient statistics for the theta by Newman factorization theorem also. Okay, now we are moving to the one more second example. This is my second example. Let x1, x2 and so on xn be a random samples from normal distribution with mean mu and variance sigma square. Find sufficient statistics. Here both are unknown. Okay, this is result. I will discuss this later. See, first I am writing likelihood joint distribution function 1 upon sigma root 2 pi whole power n. Okay, exponential e power minus 1 upon 2 sigma square summation I equal to 1 to n xi minus mu whole square. This is the joint distribution for normal distribution. We all know this. Now my question is how to find sufficient statistics. Means now I am divide this into, now I, by using the factorization theorem, what we need, I need g of theta and h of theta and h of x. Then I need what is the test statistic, that is t of x. Okay, now I am assuming this total thing. Okay, here up to here I am taking it as g of theta. Okay, and 1 multiplier means 1 I am taking as h of x. Here when I expansion this minus 1 upon 2 sigma square xi square summation is there, summation xi square minus 2 mu summation x plus n mu square. Now observe where you get more information, that is the sufficient statistics for mu and sufficient statistics for sigma square. If by understanding what you says, here summation xi is there, here mu also there, here you get most sample information, so it is the sufficient for the mu. For summation xi square is the sufficient for the sigma square. Here you get more information. Here if you take n into mu square, here you are not getting more information, here only you get more information, and here, so summation xi and xi square is the jointly sufficient statistics for the parameters mu and sigma square. Here both are unknown. Observe, now this is the important note. See, is jointly sufficient for the parameter mu and sigma square an equivalent sufficient statistics that is frequently used. See, this is x bar and s square. Note that x bar is not sufficient for mu if sigma square is unknown. This is question. Note that x bar is not sufficient statistic, not sufficient for mu if sigma square is unknown, and s square is not sufficient for mu square if u is unknown. However, x bar and x square is jointly sufficient, okay, if both are unknown only. If they are known, the formula will be different. Here it is this. However, sigma square is known, then x bar is sufficient for mu, okay. If mu equal to mu naught is known, here this is the sufficient for sigma square, summation of I 1 to n xi minus mu whole square. This result is from Rothke book. You can read that Rothke book, you can clear this. This is important result from the normal distribution. If parameters, this is important, mu is known, then it is different. If sigma square is known, then sufficient statistics is different. Now we are going to the one more example. Here also order statistics is useful. You can solve, you can, when you can draw graph for this question, you can easily understand. See what is question, e power minus x plus theta, e power minus x theta. Here x lies between theta to infinity and theta is from minus infinity in plus infinity. Now when you find joint probability, joint distribution L equal to exponential minus summation I equal to 1 to n xi. Here theta is independent of x, so e power n theta. Here you cannot apply directly Newman factorization theorem. Here we are use order statistics. When you use small order statistics means when you use x1, then you can get the sufficient statistics. For x1, first you need the PDF of what is the x1 PDF. Then we all know that for finding x1 PDF, this is command 1 minus CDF of y whole power n minus 1. Okay, this is the PDF of small order statistics. How you got means when you can differentiate with the CDF of small order statistics, then you can get this. Here you, what is the f of x? F of x is the closed form of CDF. Here CDF is what? You can find CDF by taking limit, upper limit is x and lower limit is 0. When you find CDF, you get some value, you can substitute here, then you can finally you get PDF of smaller statistics. Then you can find likelihood function. After finding likelihood function, then you can divide with what is g of theta and what is h of x, what is the statistics. Finally you got minimum, means x1 is the sufficient for the this question. You can solve this question your web. After completing all ideal estimators, I will solve this question. Okay, now we can see one more question. This question is direct question. See, here we need pi of x1 and xn is sufficient for theta. When you can formulate this question in giant distribution, you here you got theta power n pi of I equal to 1 to n except power theta. Here from the sample where you get more information means from the sample where you get more information about data means here you got more information. When you can divide different this is the test statistics. Here h of x is this. Okay, theta minus 1 also there. When you can inverse it, I am rewrite this as theta power n into pi of I to 1 to n xi, then this is the sufficient, then 1 upon pi I is the h of x function. Okay, you can solve this. This is a simple example. See, this is the example related to the conditional distribution. Let x1 x2 be IID Poisson two random variables from x1 is x2 is sufficient. Yes, x1 x2 is sufficient, but why we can say that result summation xi is sufficient for the parameter lambda. Okay, when you can take some partition from summation fi, it is sufficient. When you can take x1 plus 2 x2, it is not sufficient. Okay, this result also, I think in next slide this result also is there. Okay, x1 plus 2 x2 is not sufficient, but x1 plus x2 is sufficient. See, here we are writing conditional distribution. When you can find conditional distribution, finally you got this. If you take this x1 plus 2 x2, here it is not sufficient, because observe, here I am taking, here possible values are 0 and 1, here possible values are 0 and 1 and 2 comma 0. Okay, when you apply the Poisson distribution, finally you got 1 upon 1 plus lambda by 2. Here lambda is dependent, so it is not sufficient statistics for the parameter lambda. See, this example also, this is also example goes to the order statistics. When you find, I think small order and order both are sufficient for here. When you can find theta power n, okay, when you can calculate it, here minus theta by 2 is there, here plus theta 2 by 2, theta by 2 is there. When you find joint distribution, then here other statistics is useful. Okay, thank you for watching. If you have any queries related to the sufficient statistics, you can comment or ask me. From the next video I will discuss about completeness, all things. Also after completion, I'm try to do more examples. Okay, thank you for watching.